Hi, everybody. So today is our first lecture on Introduction to Electronics, ESc201. I am Vipul Arora in the Department of Electrical Engineering at IIT Kanpur. Let's start our discussion with the basic background that why are we doing this course. Let's talk about observations and goals. In science or in engineering, we observe a phenomenon. For example, Newton observed a falling apple. That's the simplest example I can think of. And then we have a goal. For example, we want to predict and we want to control. For example, I may want to predict in which direction will the apple fall. Will it come downwards, or it will go upwards, or it will go left or right? And then I may want to control it. Can I do something to make it fall there and not here? So to answer these questions, what can we do? To achieve these goals, one may formulate quantities and relationships between them. So one may formulate quantities like, okay, force, mass, acceleration, etc. And then one may also formulate the relationships between these quantities, that F is equal to ma. And then one may use these equations to solve, by applying these equations, by applying these abstractions, one may be able to get their desired prediction and control, etc. Now, the caution here is that abstractions are goal-oriented. And the abstractions, they do not capture other aspects of the phenomena, and they also need not capture other aspects of the phenomena. For example, this equation F is equal to ma is very good in predicting the mass, acceleration, force, or the position, etc. But it does not worry about shape, size, or color of the object, and it does not even discuss about them, or it does not even care about them, or it does not even model them. If I ask, what is the color of the ball? Can I change the color of the ball? This equation will not work. So this abstraction will not work. So there are only, and also this is one limitation. Another is that these abstractions may be valid only under certain conditions. They may not be valid under all the conditions. For example, this equation F equal to ma is not valid under at atomic levels or at speeds close to speed of light. So you all know from your physics lessons. So this is the power of abstractions. Now we can go from abstractions to abstractions of abstractions. What does that mean? One may create another layer of abstractions. For example, in physics itself, you can see in mechanics, we have a free body diagram, which is concerned with only the net forces acting on the object. But it is not concerned with the other forces inside the object. For example, the electromagnetic forces between the different molecules that make up the object, right? So it only deals with the abstraction, the abstract picture, and the relationships at that abstract level. What is the advantage? Why do we want to do that? Clearly, it is very efficient. It saves our computations. Now, that was the basic idea of abstractions and abstractions of abstractions. Now let's see, what are we doing in this course? So electrical engineering is all about, okay, it's one of the major focuses to tell what is the current, voltage, power consumption, etc. in different electric or electronic circuits and their components, etc. So that is the roughly the goal, let's say, in this course. And to achieve this, one could use physics of electrons and electric fields. One could use Maxwell's equations, quantum physics, and so many other physical models which we study in physics. For example, Maxwell equations deal with the divergence and curl, and Schrodinger wave equation is there in the quantum physics. One may deal with all of them. and find out what is the voltage, current, power consumption, etc. One can, but then is this computationally efficient? No, this is very inefficient. One may need supercomputers to solve a simple circuit. Therefore, electrical engineering comes into picture. So what is electrical engineering? It does an abstraction that, okay, without worrying about the detailed equations, can we look at the bigger picture? Can we look at the abstract picture, that just the entities which we want to predict and we want to control, and not more than that. So I'll give one example. A very quick example could be, let's say our observations are this. I know a battery can cause electrons to move in a conductor. I know a bulb will glow if the electrons move through it. And I know that the ammeter measures the current and the voltmeter measures voltage. Now, using this, what do I want to do? I have some questions. For example, I want to predict how much electric current will flow. Or I want to control, can I make the current double by replacing this bulb with another one, right? So I want to predict, I want to control. How do I do it? Solve Maxwell equations, solve quantum physics equations. That is very inefficient. So therefore, I use abstractions. Instead of solving the equations of physics, I use abstractions. I say, okay, let's formulate a relationship between voltage and current. And what I find is that the voltage is linearly proportional to the current. So V is equal to IR. So R is the constant of proportionality. And now this equation, it may very well model the relationship between voltage and current, but it ignores all the details in the filament of the bulb, in the acid in the battery, the Maxwell's equations, etc., etc. So what we have done is we have replaced the entire bulb with just one quantity called resistance, just one property of the bulb, resistance. Only that is playing a role, or that is what we are using in our abstract model. And then I have replaced the battery with just the potential or the voltage across the battery. So in this way, I have abstracted the complete unit as a black box, and just in the black box, I only know certain relationships. That's it. So we have to be careful here. Caution. Remember the constraints we have to be careful about. So this abstraction is valid only under certain constraints. For example, first of all, voltage, current, resistance, etc. must be defined for that element. For example, the bulb. It is possible that potential difference is valid only when the fields are conservative in nature, right? So you know from physics, but then to be able to abstract to this level, you need to make sure that those quantities are valid, those constraints are valid. So a bulb can be replaced as a resistance only under certain conditions. But let's say if my bulb blows out, or there is some melting element inside, then this constraint won't be valid. So you can only apply this under certain constraints. So what if these constraints are not obeyed? Then no problem. Open the abstraction layer and go to the finer details at the lower level. And there you can get some more tools to handle the situation. So do a detailed modeling. Okay, so that was the basic idea, that what we will be doing in this course. We will be studying things at an abstract level, or even abstraction of abstraction. So in this way, but our goal is very clear. We want to predict things which we want, and we want to control things which we want, and that's it. So we may, while doing this, we may ignore, or we may simplify many of the intrinsic details and lump them as a black box, or as an abstraction. Now, what is this course? In this course, we are studying the basic building blocks of everything, or in many things which we see around us. For example, the power supply. We see power generation houses, power supply in our houses, and so many electric appliances around us. So what are all these electric circuits? So we will study the basic building blocks of these electric circuits. We see so many devices around us, like microphones, speakers, etc. And they use building blocks like amplifiers, like transistors, etc. So we will be studying these basic building blocks. And then we see computers, we see machine learning, deep learning, which is all done on very powerful computing devices. And these devices are made up of electronic circuits. So we will study the basic building blocks of these electronic circuits. And then robotics, AI, and things which we all are very excited about today. So they all have electronics at their heart, at their basic level. So we'll be studying these basic building blocks, which are built, which are combined together to make so many things which fascinate us around us. So that's it. And this is the today's lecture. And then the readings which I suggest for today's lecture is this. This is a book by Anant Agrawal and Jeffrey Lang, chapter 1. And this has been shared. This chapter has been shared in the shared folder, which you will find in your LMS, hello.iitk. So that's it. And now I would like to discuss some of the logistical aspects of the course. So which are, let me go to this website. So you all know the course webpage, the course website. It's here. And so the instructors, so I am Vipul Arora, and I will be the instructor for theory part of this course. And there is also a lab component, where you will be doing hands-on experiments. So this part is taken care of by Professor Venkatesh. And you have, like, it's a huge course, so there is a team of TAs, a huge number of TAs. So, but there are head TAs who will be coordinating amongst those TAs. So, for example, we have Rahul for theory part and Nisha for the lab part. So if you have any logistical queries, then you may contact them. We'll be using LMS for this course. Hello.iitk will be our LMS, or learning management system, which we will use as the platform where we can interact outside the class. And there is forums section in this LMS, where you can post your questions. If you have any questions regarding the lectures, regarding the course content, you may post your queries there. And then for logistic queries, which you think you can't post on forums, which you may not be able to post on forums, those queries you may direct to either to your tutors or to the head TAs. And if something requires my attention or Professor Venkatesh's attention, we will look into them. But I think you can first approach the tutors and the head TAs. The timings of this course have already been announced, and I hope you're all aware. Monday, Wednesday, and Thursday, evening 5:15 to 6 p.m. in L20 will be our class. Tutorial will be on Tuesday at the same time in the tutorial block, different tutorial rooms. And the labs are on a weekly, every week there is a lab on every day for different sections. So your respective sections, you may know, and Professor Venkatesh will be sharing with you the lab details. And if he has a link, I'll post the link here. Otherwise, you get it from him. And now something about the grading part now. So the grading will be done first at the level of tutorials. Every tutorial will have a mini quiz. So finally, we'll be considering N-1 best quizzes out of N quizzes for our final grades. And we will be sharing homework problems or practice problems with you. You need not submit the solutions, and the solutions will be discussed in the tutorial and posted on the learning management system hello.iitk. But if you do those, then that will help you in the mini quiz, which will be there in every tutorial. It will be a very short 5 minutes quiz. So And then the grading part is like this. We have lab component, we have minor quizzes, which means this mini quizzes, which total everything combined will be 10%. All these quizzes will be totally 10%. And the number of quizzes may vary depending on how many tutorials we have, but total weightage will be 10%. Then we will have two major quizzes, 10% each. One mid-sem exam of 20% and final exam of 35%. And these are the dates. The major quiz one will be on 31st Jan, mid-sem exam will be on mid-sem recess, major quiz 2, and then end-sem exam. So if there are any changes, I will notify you in the class, and also I will update this web page. And if possible, also I will make an announcement on the LMS. Now, in case you miss some exam because of some reason, maybe fever or something, so for mini quizzes or major quizzes, or for the mid-sem exam, there will be no makeup. If you miss the end-sem exam, then there is makeup exam as per the DOA policy, and you have to apply for the makeup exam as per the DOA guidelines. And if you miss a lab, no problem. There are designated makeup lab sessions which you can use to cover up your missed lab. The course objectives I have explained in my talk. So we will be studying different mathematical modeling methods, basically how do we abstract from one level to the other, and different properties we will see. And these topics are listed here. We will see them in this course. Nothing to be afraid of. These are apparently new terms for you, but then once you go through them, they are very easy. They are very easy to understand concepts. We have some textbooks and reference books. Although I will be sharing with you the lecture content in the form of slides and reading materials. But in case you want to do some practice or you want to see, consult some reference books, then you may go through these. So thank you very much, and enjoy the course. And we are here for a good learning experience, and feel free to reach out to us for any questions on the LMS. And thank you. I look forward to going through this course with you, and I hope you have a very good learning experience. Thank you very much.